Hello, everyone. Welcome back to our channel where we unravel the mysteries of artificial intelligence and machine learning. If you're curious about how AI systems learn and why they sometimes don't perform as we expect, you're in the right place. Today, we're going to dive into a crucial concept in AI called underfitting. So, grab a comfy seat and let's get started. Now, you might be wondering, what exactly is underfitting? Well, underfitting is a term used to describe a situation where a machine learning model is too simple to capture the underlying patterns in the data. Think of it like trying to fit a square peg into a round hole. No matter how hard you try, it just won't fit. So, let's break this down further and see how it can impact AI performance. Imagine you're trying to predict the price of houses based on various features like size, location, and number of bedrooms. If you use a simple linear regression model but the relationship between these features and house prices is actually quite complex, say, it's curved or has multiple peaks, your model will struggle to make accurate predictions. This is where underfitting comes in. The model is too simplistic, failing to capture the true complexity of the data. Let's consider an example. On the left, we have our underfitted model. You can see how it fails to follow the trend of the actual data points. The predictions are far from reality, and as a result, our model's accuracy is quite poor. On the right, however, we have a well-fitted model that adapts to the data's complexity, capturing the essence of the relationship between the features and the target variable. So, how do we know if a model is underfitting? One key indicator is the model's performance metrics. For instance, if both the training and validation errors are high, it's a strong sign that your model is underfitting. Let's say you're working with a dataset of 1,000 samples. If you train a linear regression model and find that it has a high mean squared error both on training and validation sets, that's a clear indication of underfitting. In contrast, a well-performing model should have lower errors on both sets. To understand this better, let's draw a simple diagram. Here's our dataset, and here's our model trying to fit it. The red line represents our underfitted model. As you can see, it barely touches the data points. The blue line represents a well-fitted model closely following the data points. It's essential to find the right balance between complexity and simplicity. Too simple, and we underfit. Too complex, and we overfit. Now, what causes underfitting? It can stem from a few common issues, including choosing the wrong model, insufficient features, excessive regularization. To avoid underfitting, it's essential to select an appropriate model based on the data you have. You can also experiment with adding features or using more complex algorithms. For instance, decision trees or neural networks might provide the flexibility you need to capture complex relationships in your data. To wrap it up, underfitting occurs when a machine learning model is too simplistic to capture the underlying patterns in the data. It can lead to poor performance and inaccurate predictions. By choosing the right model, ensuring you have enough relevant features, and avoiding excessive regularization, you can help prevent underfitting in your AI projects. If you found this video helpful, don't forget to give it a thumbs up and subscribe for more insights into the world of AI. And let us know in the comments, have you ever experienced underfitting in your work, and how did you overcome it? Until next time, keep learning and exploring the fascinating world of artificial intelligence.